In this figure, TU is the tangent. So very straightforward. You should realize that there is an angle in alternate segment. These two angles are the same, and then together with one common angle here. So we have a pair of similar triangle already. UTV is similar to WTU. Even though it's quite simple, but you better draw in the graph to make them in the same direction first. It's also useful in the following parts. So our argument is, since UT is tangent of the circle given, therefore angle TUV is equal to angle UWV. The reason, we need to write down reason because they use proof, this command. The reason is angle in alternate segment. And then we have the second pair of angle. So angle WTU is equal to angle UTV, common. Therefore, with two pair of angles equal, we can say that they are similar already. Triangle TUV similar to triangle WTU. The reason is AA. There is a reference called AA. In part B, it's given that VW is a diameter of C, so this is very important information. There is a center in the midpoint, and also immediately we know this angle is angle in semicircle. It is 90 degrees, and it may be useful later on. So T to U is 780. Write down here, that means 780 here, at the same time is 780 here. And then TV is about 325. 325, so this is 325. A similar triangle, we have a complete pair of sides, so we know their length ratio. The ratio is 780 divided by 325. So that means every length is multiplied by 2.4 times. Then we get the longer length here. We have to express the circumference of C in terms of pi. To get the circumference, that means we are going to find R or D diameter. That means we are interested in what is WV. Our target is to find out WV, so we can find out WT first, then we subtract 325 from it. A very typical application of a similar triangle. This to this is equal to this, so we write down WT here. WT to this length, 780 should equal to 780 to 325. So part B, WT divided by 780 equal to 780 divided by 325. So, or more common sense, that means 2.4 times that we measured just now of this length. This length times 2.4, so straightforward, is 1872. So total length here is 1872. That means WV alone, the diameter, WV is equal to 1872 minus 325, 1547. Therefore, the circumference that we learned in primary school is pi times diameter. So that means pi times 1547 is 1547 pi cm. Someone claimed that the parameter of triangle UVW. So UVW consists of three sides. We have one of them already, 1547. We want to know another two here. So if we separate it and then refer to the graph here, we are talking about this line and this line. Now the problem is we don't know exact length of any of these two lines. We know that they are related, but we don't know their exact length at this moment. But if we know their relation, then we make good use of the relation first. Don't let two unknown, otherwise there are too many unknowns here. If you let this length be L, then you know that every length is 2.4 times here. So the corresponding length here is 2.4 times of L. If we put it back here, it is L and 2.4 L. Oh, it's because this is diameter. We know this is right angle, so we can apply Pythagoras theorem to write down the relation between these three lines. Then we can get L. That's why in using a similar triangle, rather than just memorize the procedure how you set up the formula, the more important thing is you know that you are going to multiply every length by a certain ratio, and that ratio is very important. So we let UV is equal to L, then WU is equal to 2.4 L, and since WV is diameter, therefore we know that angle WUV is equal to 90 degrees. So we can apply the Pythagoras theorem. L squared together with 2.4 L bracket square is equal to 1547 squared. So in total 6.76 L squared is equal to 1547 squared. We get 595. And then what it's asking is about the total parameter. So only getting L is not enough. We also need to get WU. So the parameter is equal to 1547 plus 2.4 L plus L. Is 3570 cm. We are going to compare with meter, so change it back. That means 35.7 meter, which is larger than 35 meter. So we agree with this statement. Just make good use of the similar triangle, then you find that it's quite easy to solve.